Welcome to the fourth video in this short series on creating a die set. We recommend you watch the videos in order, so go to the first if you haven't seen that one yet. In this video, we will test the die set by changing component properties via the setup dialog. We will also start to add standard components from the catalogs. We wish to thank you for your interest shown in Cimatron and hope you will search out other videos in this series. We now have quite a few plates in our die set. Let's visually change some things for clarity. You can use this option in the feature tree listing to see things in wireframe or transparent mode. Open the setup on the strip layout tab, and we can change the dimensions of the strip we've been building to values that we will use in this instance. We'll update the plate sizes and the thickness of the coil. Let's make sure everything updates and everything is attached. On inspection, the widths and overhanging margins updated and the shoes moved. So it looks like this has been successful. Open the setup on the General tab. Let's make a quick adjustment to these values and change the die plate length from 150 to 200. That test was successful. Now let's change the maximum to value so we can select the size that wasn't in there before. Let's make the step size bigger too. Now you really can see it. So you could really push these values to see how flexible things are, how robust it is, and when you're satisfied, save it. Now we can test this assembly using a real strip and check if it finds all the values that we worked to in the strip. Open a strip file and add our die shoe file as a duplicate. When we built the die shoe file, we located all the UCS at the beginning of the strip, so let's position it at the midpoint on the end of the strip. Initially, it looks good. The shoes have sized up to the correct width and length, but you can see the strip is protruding at the end. When we look closer, we can see the strip is out of position. Our gaps and distances are good, so what we constructed is working, but the positioning is incorrect. The issue is that the file uses an active coordinate system, and that has to be active in the die shoe file when we save it before we place it in this file. This is relatively simple to fix. Close the file and go back to our die set assembly. Let's take a closer look at our datums and datum planes. We can see the active coordinate system is shown as the red datum with the 3 purple planes, and that is where the strip was positioned. To fix this, we will activate the main assembly and then create a new coordinate system. Select UCS by geometry. Place the new UCS on the leading edge of the die plate by selecting the midpoint filter and orient the x-axis along the length of the die plate. Let's give the UCS a very clear name. And make sure it is active before we save it. And we need to save the file. Hide the datums for clarity. Reopen the strip file. And click Assembly, add the duplicate. and pick our die shoe assembly file. Place it by pick as a subassembly. Select the leading edge using the filter for points. And select the midpoint. And pick the leading edge of the strip. This immediately looks better, so let's check all our gaps and our clearances. Click OK to accept. Close the strip file and we will continue in the die shoes file by assigning properties to each of the plates in the die set. Select a plate in our tree and right-click to go to Properties. Here, we will assign such things as Material, Catalog, and Category. When we start making changes, you can see the 3 buttons for Redo, Undo, and Save become available. Scroll down in that catalog listing. We see that these are all our supplier catalogs. If there is one already in there, we can select it, or we can create one by typing it in the field. Do the same thing in the main category, and add a subcategory as an identifier. It's a die plate, so scroll down until we find die plate and make the assignment. Add the rest of the parameters, select parametric, mark that it requires machining. We want it on the BLM, so do not select Ignore. The short type is important. When we assign it as a die plate, we identify that we will need to cut relief holes that we have saved. Let's go back now to the next one. Work your way down the list, right-click on each plate, and assign the properties. Select the material. You can see these dialogues can be edited at any time. This is not a sequential process. This is a backing plate, so we'll look for die backing plates. Mark the boxes that we need. If you want, you can add the hardness and the heat treatment as well. All that information will appear on the bill of materials. We don't have the material we need for this shoe. When we look on our global material table, it isn't here either. Ideally, we would update the global material table to make it available for all users, but for now we can type in the data. For example, this is a hot road steel burnout. Update catalog, category, subcategory, short type. Do the same for all the remaining plates. Now let's assign properties to our main assembly. We will assign some properties that will be used by the die design guide. We'll come back to this later. For catalog, type in die sets. In the category selector, you can see there's lots of different types of tools, including die sets, punch units, forming units, and many more. We'll pick die sets. Set the subcategory as die shoes, subassembly type as a die assembly, and set the short type as DP2 die plates and save. Now we can save as and give the file a different name. We started with a file called die shoes, but that doesn't describe it well. So let's call this our standard millimeter die set. Now we are creating some standardized naming. Let's close this file and then open the browser to rename the directory. Now it fits nicely among all the other die components that we've built up over time. Open the directory and you can see the icon for the main assembly looks different to make it easy to find. Right-click on it and select Delete Unused Files and select Delete Unused Files again to get rid of assembly names or components that aren't attached, such as components that were added and then deleted. Open it one more time to check our standard millimeter die set is working right. Right-click on the top bar and we can now open up the tool design guide. Click Add Die Sets and then click the Browse button next to the directory drop-down. Browse to the new folder that we've built along with our subassembly in the die set. This is shown here because we assigned properties to make the components available in the die design guide. Here you can see the die shoes and the actual die set we created. Thank you for reviewing this presentation. Look for our final video in this series where we will be talking more about die design.